In this video, we're going to talk about using forces with ice. It's really important to use forces so we can control our ice particles and apply certain types of effects like wind, gravity, and different things like that. So we're going to look at that in this video. First thing we need is to go ahead and create ourselves an ice particle emitter here to get started. So I'll go over to the primitive menu and pull up a polygon mesh. Disk will work out just fine. Let me go ahead and maybe I'll adjust the inner radius. And that's about it. That's all I'm going to do with this disk. Then I'll simply go over here to the ice menu, select create, emit particles from selection, and there we go. Okay, so let's hit Alt and 9 with the point cloud selected to open up the ice tree. And let me just go ahead and resize this window so we can see this a little bit clearer, a little bit better. Alright, so here's our ice tree. By default, this is what we have when we hit play. So let me go ahead and increase the number of frames here to about 1000. Should work out just fine. And there's our little particles right there. Okay, let's start to adjust this a little bit before we add forces to this. Let's go ahead and give it an age limit. So we'll open up the preset manager, type in the word get, and the get particles down here, get particle age is here, which is the wrong node. Idiot. Do that again. Starting again in 3, 2, 1. So what we'll do is we'll go up here and type in the word set, and here's the set particle age limit node. Let's drag and drop that into the ice tree here, and now we can set the particle's age limit. So we'll plug its execution output port into the input port right here on the emit from surface compound called execute on emit 1. If we open this up, we can see that the age limit by default is 4 seconds. We'll go ahead and leave it at 4 seconds. We're really not interested in the age limit too much. So let's go down here, move these nodes around a little bit to give us some more room, and let's go back to the preset manager. Now what we want to do is type in the word delete, and the node that we're trying to filter out here is the delete particle at age limit node. So let's drag and drop that into the ice tree, take its execution output, and let's plug it into port 2 over here of the ice tree. Basically, you just want it to be plugged into a port that's in between this tan port up here, the emit from surface compound, and down here the blue node called simulate particles. Okay, perfect. So now if we go back to the first frame of the animation and play again, we should see that after about 4 seconds of life, the particles just die off up here. Perfect. Alright, let's also turn on loop for animation down here, just so this loops over and over again. Okay, so let's go back to the ice tree real quick, and what we want to do now is start to apply forces to this. By default, you can see that the particles are being emitted right here off of this disk, and because the disk is facing up, the particles are going up. So for example, if I hit play and I select a disk and I start to rotate it, you'll see that the particles will pretty much fire off in whatever location, whatever direction this disk, which is the emitter, is facing. Okay, so let me stop the simulation there. Let's go back to the ice tree. Okay, so how can we control the direction and the speed of the characteristics of those particles when they're being simulated? Well, if we open up the PPG for the emit from surface compound, we have a few settings we can control here. For example, we can go ahead and set which direction these particles will emit from. So right here in this option called select emit direction, we can choose to use the emit location normal of the object, or we can use an initial direction vector, which is basically a fancy way of saying choose what direction these particles are going to fly off in. So for example, right now by default the direction is set to Y, which is up, in a +1 value. This means that they're going to go up. If I were to type in, say, -1, and now we go to the first frame of the animation and hit play, you'll notice that the particles are shot down. That's because negative means down and positive means up in the Y direction. Okay, so let's go back and set this back to 1. What happens if we start playing around with the numbers on the X direction and the Z direction? Well, as we can see in our global axis indicator down here in the bottom left of our viewport, X is this way here, left and right, and Z is forwards and backwards. Okay, so let's go ahead and play around with X. If we type 1 for X, what will happen now is that the particles are going 1 unit up, 1 unit to the right, positive in X. If we go ahead and If we edit that out of the video, 3, 2, 1. If we go ahead and type in for x, say -1, now the particles are going to go to the left because positive x is to the right and negative x is to the left based on the view that we're looking at this viewport in. Okay, so hopefully I should give you a good idea of what these different direction vectors mean and how to control them. But usually, not always, but usually you want to control the direction and the characteristics of these particles in a different manner. And the way that we can control these particles in a different manner is using forces with ice. Okay, so that's what we're going to look at in this video. And of course, we also have this speed parameter, so we can slow down particles or we can speed them up. And we'll look at how to use forces to control the speed and velocity of particles as well. So we have a lot of control with forces that we can exact upon these particles. So I'll close this PPG. And let's go back to ice over here. Let's also stop the animation there. Okay, so how do we start applying forces to our ice particle system here? Well, it's actually pretty simple. Let's go back to the preset manager. Let me just increase the size of this a bit. And make sure that you're under ice nodes here and that you are set to particles and not deformation. And down here you'll see a category called forces. So it's pretty simple to find. And we have many different forces and nodes that we can use in conjunction with our particles. So let's start to look at all of these one by one and see how they all work. Now, before you can apply forces in ice to your particles or to your ice tree over here, we need an add forces node. So let's drag and drop that in here in the ice tree. The add forces node, what it's going to do, it's going to take forces that you apply to your ice tree and execute them here on this green execution node. So let's go ahead and plug it in. You'll notice though that we don't have any new ports. Well, we want to go ahead and plug in the add forces port. It's good to plug it in before the delete particles at age limit port. And because we don't have an open port there, this is very easy to do. All we have to do, right click on port 2 and go ahead and click on insert port before. And that'll open up port 2 and move the delete particles at age limit node down one port to port 3. So let's take the add forces node and plug it into port 2. Now it's in between the emit from surface compound up here and the delete particles at age limit compound down here. So here's our add forces node. If we open it up, you'll notice that the PPG is pretty simple. We basically just have this force 1 parameter and we can choose what force we want to exact upon our particles. We can force it in any vector, x, y, or z, and then we can choose these sliders here and input a number of our choosing, whatever we want. Let's close that. We don't want to really control particles with that very simple and arbitrary parameter. So let's go ahead and start to add some forces from this actual preset manager over here where all the forces are located. Okay, so we have a gravity force that we can apply, so let's go ahead and apply that gravity force. Let's take the gravity force, and to make it work, simply take its output and plug it into the force 1 port of the add forces node. Now what will happen is that the gravity force is piped into the add forces node, and that then gets piped on over to the ice tree. So let's open up the gravity force PPG here, and notice that it has a very simple parameter set, x, y, and z. We can choose which one of these vectors we want to use as gravity. By default, it's set to the y direction and it's set to -9. So now if we hit play, you notice that the particles shoot up a little bit and then they fall down. So let's do something a little bit different here. Let's close the PPG. Let's go back to the ice tree. Double click on the emit from surface compound right here, the tan one, to open up its PPG. Here's the speed, which is set to 5. Let's increase the speed and watch what happens in the viewport. You'll notice as we increase the speed, the particles get shot up higher. Basically, it's working almost like a water fountain, where the water is being shot up by the force of the fountain itself, but then gravity takes over eventually and defeats the force of the water fountain, and the water particles just fall back down to earth. So let's increase this to say value speed of 20, and we can see that the particles are now shot up higher. So you can see how this behaves pretty realistically. Let me actually lower that down a little bit. Something like that looks pretty good. Okay. And you can see how this reacts pretty realistically. The gravity effect is in fact taking control and affecting the way that our particles are simulating in our scene. So it's a pretty simple example of how these forces work. So let's look at a few other forces here. Let's open this preset manager up and let's look at the wind force. The wind force is pretty interesting because, as the name indicates, it simulates a wind. Okay, but now you'll see we may have a little bit of a problem. We have a gravity force plugged into the add forces node, so if we want to use the wind force, we probably can't use the gravity force, right? Well, no. The good thing about ice is that using this add forces node allows us to combine different forces. So we can literally combine all the forces we want. We can combine the gravity force and the wind force to get a more realistic effect. So let's take the output of the wind force, plug it into the new force 1 parameter down here, and that'll create a force 2 port automatically for us. So now the add forces port node is taking the values of the gravity force and the wind force and combining them together and then piping that on over to the ice tree. Okay, so let's take the wind force, double click it to open up its PPG. Let's collapse the ice tree view up there and see some of these parameters. We have a wind speed parameter, we have wind strength, and we have wind direction. So we can choose what direction the wind is coming from. In this case, it's coming from 1 unit positive in the X. So it's actually pushing to the right. And you can see how the particles are actually flying off to the right. And they're being affected by gravity at the same time, which explains why the particles are going downwards like they are in my viewport. Okay, so let's change the wind speed. We can reduce the wind speed so the particles aren't pushed so far away. And we can also increase the wind strength or decrease it. So using this wind force node, we can actually have a lot of control over our particles. So if you create something like a fire or smoke, maybe a building's on fire or something like that, you can apply this wind force and make the simulation, make your animation look very realistic with wind forcing itself upon these particles just the way that it would in real life. Okay, let's go back to the ice tree. Let's open up the preset manager and look at some other forces here. We also have a force called Coagulate. So let's bring that in here, close the preset manager. What I want to do so that we can see the coagulation force in effect and not have it be affected by the gravity and wind force, though we could if we wanted to, but for illustration purposes, I'll disconnect both the wind and gravity force and move them over here to the side. I'll take the Coagulate force and I'll plug it into the force 1 of the add forces node. So now only the Coagulate force is having an effect in my scene. Double click the Coagulate force to open up its PPG. Let's have a look and see what it does in our scene. Okay, what the Coagulate force does. It essentially causes the particles to behave very similar to the way that mercury behaves. If you're familiar with mercury, which looks like a liquid metal, and it's been used in movies before and in film, mercury tends to attract itself and pretty much form these sort of puddles. The Coagulate force works in a very similar manner to mercury or liquid, something like that, where the particles can be attracted to each other. Now here in the PPG we can see we have a lot of parameters that we can use to control this attraction force between the particles. So let's go ahead and start playing with them and see how we can control this. But before I do that, I want to go back to my ice tree and change the shape of my emit from surface compound. I want to change it from point to sphere. So we have these little spheres in our scene. Increase the size a bit, maybe to about 1 looks pretty good. Okay, we close that PPG and open up the Coagulate force PPG again. So here's our particles. And you know what? The speed is a little bit high as well, so let's change the speed on that. Let's reduce that speed by a good amount. Something like 5 will do pretty good. 5 is the default, by the way. And let's open up the Coagulate force PPG. I'm going to pin it down as well so it doesn't go anywhere. Okay, so here's our spheres, and let's also switch to shaded mode over here. Alright, so there's our spheres. You can see how they're kind of moving around and attracting each other, and it might be a little bit hard to see. So you know what we'll do? We'll go back to the emit from surface compound. We'll reduce the rate by a good amount. The fewer particles there are, the easier it's going to be to see the effect. And let's also reduce the speed a little bit more. Okay, so speed of a little bit over 1 looks like it's going to work out just fine. Okay, so make sure to coagulate force PPGs open. Here's our particles. They're flying up, and you can see them sort of start to get attracted to each other. And again, this might be a little bit difficult for you to see, so let's do one more change here, I promise. We'll reduce the size a little bit here. Okay, so it's a little bit easier to see. And just one more, let's increase the age limit here to about 10. Will work out just fine, just so we can see this a little bit better. Okay, now you can clearly see the clumps of particles. If you look very carefully, when the particles are emitted down here, watch them as they're emitted, and then they clump up together. When they get within a certain threshold, a certain range of each other, a certain distance, they'll clump up and they'll become attracted to each other and stick together the same way that mercury does when mercury is close to itself. The mercury tends to attract itself. So we can see down here we have a parameter for attraction strength. It's set to 0.2. If we increase that parameter, now you'll see the effect is pretty drastic. As soon as the particle is emitted, wham, they all start to attract each other and form these little clumps of particles, basically, little clusters. So we can also change different attributes here, like the coagulation size. For example, if we increase the coagulation size, and let's increase the attraction strength here. And that didn't work out exactly how I thought it would. Okay, so go back here. All right, so forget that parameter. Start again in 3, 2, 1. So you can see as we increase the attraction strength, the particles tend to clump up more. They're very, very attracted to each other and form these sort of clusters. Okay, we can also increase the coagulation drag. So now there's a drag sort of force that's applied to the coagulation. We can see it here as we increase and decrease the parameter. We can also increase the amount of repelling between these particles. So we can tell them to repel each other. And you'll notice that now the particles come together and they sort of reject each other. They still stay clumped up. But if you look at them carefully, you'll notice that there's some kind of a wiggling effect, sort of a jittering between the particles. And it's because they're repelling each other. So they're coagulating, but they're trying to repel each other at the same time. So they don't just come together in one shot and then stay together. They'll sort of have this noisy effect where, as you can see, when I increase the repellent strength by a lot, the particles sort of jitter around and sort of try to fight the effect of coagulation. Okay, let's have a look at how the curve here can be used to control the attraction and the strength over the distance of these particles. Okay, so let's take this keyframe over here and let's bring it up. Now you're going to notice a different type of behavior here. The particles are kind of a little bit more radical now, and what happens is now particles from very far away can attract each other. That's why you see particles sort of clump up, and then suddenly it'll go, oh wait, let me clump up with that cluster that's over there, and they'll fly off to another cluster and clump up, and sometimes they'll just break apart and form up other clusters. So you can use this profile curve to control that. So for example, we can move the first keyframe down here so it has a low attraction strength value. So down here, they don't get attracted too much. See that? They're kind of just spread out. They attract themselves just a little bit, but not too much. And then when they get up here, so you can see from the profile curve, when they get up here to this point, you can see they're very attracted to each other. You can see them kind of just going crazy, going a little bit berserk there, and attracting themselves and getting stuck together. We can also change the cutoff distance here. And you can see as we increase that, the particles behave completely differently now. So this is a pretty awesome effect, and these parameters are you can animate these parameters. Don't forget that when you have the little green icon here on the left, you can set keyframes and animate these parameters. So you can do a simulation of some objects coming together like this, and then suddenly later on in the animation they just break apart like so. So this gives you a lot of flexibility and power with how you work with particles in ice. Coagulation force there is pretty neat. So I'll disconnect the coagulation force there. Okay, now let's look at some other forces. Let's open up the preset manager here, and let's go ahead and let's have a look at the drag force. Drag force is located right here in the preset manager, same place we've been getting all of our other forces from. And let's go ahead and pull in the drag force here. And let's have a look at our particles in the background. That's the particles firing off without any forces, basically just the default emission direction and speed coming from the emit from surface compound. So let's connect the drag force to the force 1 of the add forces node. And let's open up the drag forces PPG and see what we've got. We've got two simple parameters. And now that the drag force is applied, you can see what's happening to the particles. They're being emitted and they're sort of just slowing down and coming to a complete halt. Okay? What happens is that the drag force applies a force of drag on these particles. The way that you would expect drag force, say, of wind resistance on an object flying through the air, or an object going through some kind of a very dense environment, like, say, underwater. So the drag force can be very useful for doing simulations of something going underwater. So you can do some particles kind of just floating in the water and having drag force from the water applied to them. So we can increase the strength, which you can see it's pretty strong right now. It's not letting the particles do much. Or we can decrease that strength by a good amount and apply very little drag. So here's the drag force being applied. You can see that we have a very small value, only 0.006. The particles are being emitted at full speed, and as soon as they're emitted, the drag force starts to apply itself to the particles, and they start to slow down until they basically come almost to a complete halt up here. We have two ways that we can apply the drag force to our particles. We can select simple velocity based, or we can go with physically accurate. I like to go physically accurate most of the time, as I find that it gives me the best results and lets me work a little bit better with this force. So we can increase the strength here, and you can see how the particles are emitted and they start to slow down, and they sort of start to clump up there. Now they're not being attracted to each other. This isn't working like the coagulate force compound. This just works like if there was some kind of air resistance or resistance of an object trying to move through a very dense environment, again, like underwater. Okay, so let's go back to the ice tree here, and let's look at another force. Okay, we're going to edit that part of the video and end it now. So 3, 2, 1. Okay, so those are some of the ice forces that we can use with our ice particle simulations. There's a lot more, and we're not going to skip them. I'm just going to end this video here because it's been running for a little while. So I'll end this video here, and in the next one, we'll continue working with more of the ice forces that are available to us with ice in exercise 7.